In this video we're going to look at how we can use radian measures to work with arc length. So if this diagram shows a sector of a circle, so it's an arc bounded by 2 radii, then the arc length is this curved part here. Now if I had an entire circle, then the circumference of that circle would be 2 pi r, and I would multiply that by what fraction of the circle I've got. So if I'm working in radians, that fraction of the circle will be theta, which is the angle in the centre, over 2 pi, which is a full turn. So I can then simplify this formula down to just r theta. So the arc length is given by r theta. So the arc length is given by r multiplied by 3 pi over 7, which is then 6 pi over 7. And I could leave my answer like that, but because it's a length, it's possibly easier if I do it as a decimal. So I'm just going to put 6 pi over 7 into my calculator, and that will give me 2.69. So 3 significant figures. They also have to be able to work with worded problems on this topic. So here we're told the minor arc of a sector AB, where ACB is an angle of 0.5, and A, B and C lie on the circumference of a circle with radius of 5. So let's do a little sketch to help. Right, so we have a circle. We're looking for a minor arc AB. So the minor arc tells us that it's going to be the smaller arc. So it's, for instance, could be here. So there's A and there's B, where ACB is an angle of 0.5 radians and AB and C lie on the circumference of a circle. Now, if I have the point C between A and B on the minor arc, then I'm going to end up with an obtuse angle. So it has to be that C lies somewhere else. From knowledge of circle theorems, it doesn't matter where C is around this point, it's always going to have an angle of 0.5. We can also use the fact that if C was down here somewhere, then we'd have a cyclic quadrilateral, and so the angle, if it was here, would actually be pi minus 0.5. Now if this is the centre of my circle, then I'm going to use a different circle theorem, which is going to tell me if this angle is 0.5, then this angle here is 1, because the angle subtended at the centre is double the angle subtended at the circumference. So that means that this angle around here is going to be 2 pi minus 1, if I needed that. But that's actually, look, what we want to find. We want to find this arc length here. So we need the radius. Now we know the radius is 5. And we now know that this is 1. So we know the angle. So we now can use our formula. So L equals r theta. So L equals 5 multiplied by 1. So we have an arc length of 5 centimetres.